Hi guys, welcome to Dr. Zahir Math. Zahir here. In this video, we'll break down one of the most powerful tools in multivariable calculus, that is the gradient vector and directional derivatives. I'll show you what they really mean, how to calculate them and why they are so useful. All made super simple with examples. Let's get started, right? 14.6 module 3 gradient vector and directional derivatives. Two rules you need to study in this exercise. Number 1 is gradient, number 2 is directional derivative. What is the rule for gradient? Gradient is equal to grad f. In short, we can write grad f. In mathematical way, that is notation, we can write del f. This is called del, okay? Del f is equal to vector bracket, this is the vector, fx, comma, fy, comma, fz, and you need to calculate at the point P. That means sometimes the point will be given and you have to put the point, that is x equals, y equals and z equals. Okay, right. The next formula for directional derivative. In short form, we call it as dd, which is equal to, the formula is grad f at the point P dot u vector. And the formula for u vector is v vector divided by absolute value of v vector, right? So if you want to find directional derivative, you need gradient. Suppose the question comes, find the directional derivative only. So in that situation, you need to find grad. Why? Look at the formula of directional derivative. Grad is there, right? Gradient is there, right? Understand? Okay. So it's very easy. Just remember the two formulas. Let's go to the first question. Find the gradient of f at the point 1, 3, 0 and find the directional derivative at 1, 3, 0 in the direction of v is equal to I plus 2j plus minus k, right? So the function is missing. Let me take the function. Find the gradient of the function. Gradient of f is equal to, right? The function is missing. F is equal to x sine y z. This is the function, right? Let's start the solution. Okay, right. The solution is function f is equal to x sine y z. Y is an angle, right? Okay. We are going to do first is grad f. What's the formula for grad f? Vector fx, partial derivative with respect to x, fy, partial derivative with respect to y, and fz, partial derivative with respect to z. So this equals vector fx. So what's your function? F is equal to x sine y z, right? Before going to this, let me explain a few things about the derivative. Then I will come back to this question, okay? Right? There is no place. I will go back to this exercise, right? So this is 1 page, 2 page, and the third page I will go, right? Suppose you have a function f is equal to sine x. What is the derivative? df divided by dx, which is cosine x, right? Suppose you have a function f is equal to sine of x plus y. There are two variables are there. If you want to take the derivative f with respect to x is cosine x plus y. After that, derivative of x plus y with respect to x is 1 plus 0 partial. Suppose you want to calculate fy, cosine of x plus y, and the derivative of x plus y with respect to y is what? X derivative is what? 0 and y derivative is what? 1. So keep your example. Suppose you have a situation f is equal to sine product xy. Okay. So what is the derivative? Partial derivative with respect to x. Sine derivative is cosine xy. After that xy, you need to take derivative with respect to x. So xy, we are doing with respect to x. Y is a constant. X derivative is 1. Clear? Fy, we want to take cosine xy and derivative of xy with respect to what? Y. So x is a constant and derivative of y is what? 1. So keep this idea in your mind. The same idea we are going to follow. Okay, right. So let's go to the first question. Right. So we are going to find out the derivative with respect to x. Now here is the function and here is also the function. This is purely in terms of x. There is no x. Keep in your mind. So you are taking the derivative with respect to x. The derivative of x is 1 and then don't touch sine y z. Let's go to the derivative of fy. Fy, when you are doing x is a constant, keep it as it is. Sine derivative is cosine y z and y is a derivative with respect to what? Y. So 1 times z. Understand? Understand? Once again repeat. Sin yz derivative is cosine yz, and yz derivative with respect to y. Look here, yz derivative with respect to y. So y derivative is what? 1, and z is a constant, so z. Comma, right? This is comma. And you're going to take f is z. Okay, right. What is the derivative of f is z? X is a constant. Sin y is z, you're going to take with respect to what? Z. So cosine y is z. After that, y is z, you're taking with respect to what? Is z. So y is a constant, z derivative is 1. The same idea. So what happens now? This equals, it is sine y is z, comma. This is multiply, this is an angle. So take this to the front. So x is z, cosine y is z, okay, comma. This is multiply, take it to the front. So this is xy, cosine y is z. Close the vector bracket. Yes. Now we need to find grad f at the point. What is the point given? 1, 3, 0. This is the point given. So let me put this point. So it means what? Sine, you're going to put y is equal to 3, z is equal to 0. X is 1, z is 0. And cosine y is z, which is 1 times 0. And comma, right? Y is z, y is what? 3 times, sorry. Y is 3 times 0, right? The next is xy. X is 1 and y is 3. And cosine y is z, which is 3 times 0, right? So this equals vector bracket, right? Sine 0, this one, comma, and anything multiplied by 0 is 0. And this is 1 times 3 cosine, this is 0, right? 3 multiplied by 0 is what? 0, and then vector bracket. How much is sine 0? 0 and 0. And cosine 0 is equal to what? 1. So this is your grad f at the point 1, 3, 0. At the point what? 1, 3, 0. So this is your grad f. This is your grad f. Okay, right. So the next we are going to find out what? Directional derivative, right? What is the formula for directional derivative? The formula for directional derivative is, I gave you the formula, I think you know. Directional derivative, which is given by the formula dd. Grad f at the point P dot u vector. What is your u vector? V vector divided by absolute value of v vector. Okay. So u vector is given in the question, right? V vector is given in the question. How much? I plus 2j minus k. I plus 2j. So this equals I plus 2j minus k vector divided by absolute value, means square root. 1 square plus 2 square plus minus 1 the whole square. So this equals I plus 2j minus k vector divided by square root of, use calculator or in the mind, 4 plus 1, 5, 5 plus 1 is 6. So it is root 6. So I'm going to write in the vector bracket model how it is 1 by root 6, 2 by root 6, minus 1 by root 6. Okay, right. So this equals now grad f. What is the answer you got? Grad f 0, 0, 3, right? So the answer you got is 0, 0, 3, right? And then dot vector, you get 1 by root 6, comma, 2 by root 6, comma, and minus 1 by root 6. So this equals vector. So I with I, j with j, k with k. So 0 plus minus 3 by root 6. So therefore, directional derivative is equal to minus 3 by root 6. Keep in your mind, directional derivatives always be a constant. It's a number. Keep in your mind. It's a number. Okay? Right. So it's clear. Very easy, all of you. How to find the gradient and directional derivative. Right. Let's do one more question in this exercise. Now the question is directly coming. Find the directional derivative. If the question comes directly directional derivative, it means you are going to find out what? You are going to find first is what? Grad. Why? Because directional derivative dd is grad f at the point np, right? Dot u vector. What is your u vector? Which is v vector divided by absolute value of v vector. Okay, right. So let's find first grad. Okay, so let us find grad f, which is equal to vector fx, fy and fz, which is equal to vector bracket. This is your function f. Okay, right. So we are going to do what? The derivative with respect to x. Come on, say what is the derivative with respect to x? The derivative with respect to x means we are going to do with respect to x square 2x y cube is a constant minus 0 comma fy. We are doing with respect to y. X square is a constant, y cube is 3y square minus 4y comma, okay, right. And we are going to do with respect to z. Is there any z here? No, so it is 0. So this is equal to vector bracket 2xy cube comma 3x square y square minus 4y comma 0, right. Now we are going to find out grad f at the point P. What is the point P given in the question? At the point P is given as, the point P is given as 2 comma minus 1, right? 2 comma minus 1. So the point is 2 comma minus 1. It means z is 0. There is no z. So vector bracket 2 times x, it is 2, and y it's minus 1 power 3, and 3 x is 2 square and y is minus 1 square minus 4 times y, which is minus 1 comma 0. You can also restrict this as two-dimensional picture also, no problem. No need to write the 0 also. So 2 into 2, 4. 4, this is 1 is minus 4. Vector bracket, this is minus 4. This is 4 and this is 1 and this is 3. So 3 into 4 is 12 and this is plus 4. Plus 4 or minus 4? 4 into minus 1. This is 12, right? This is minus 4. 3 into square, 2 square, which is 3 times 2 square, and this is minus 1, right? So this is 2 square is 4, 3 4 is 12, right? And 12 plus 4, which is going to be 16, right? 12 plus 4 is 16 bracket. Okay, let me check again, right? 3 into x square, which is 2 square, right? Y square, which is minus 1 the whole square, minus 4 times minus 1, because y is minus 1, right? So this is 3 times 4 and minus 1 square is 1, and this is minus of minus is plus 4, right? So 3 4s are 12. 12 plus 4 is how much? 16, right? So it's going to become what? 16, right? Let me check the derivative also. Derivative is correct or not. So we are going to do with respect to y. I made a mistake, right? Yes. What's the derivative with respect to y? When you are doing with respect to y, this is x square is a constant, 3y square. And when you are doing with respect to y, this is minus 4, right? It is not y. So it is going to become, there is no y here, it is minus 4. Minus 4, this one, yes. So this is not going to become y, and this is all cancels, okay, right? So this is how much it's going to become? This is 4, 12. So it is 12 minus 4, which is equal to 8. So this is going to become what? 8. And comma 0 also you can write it, no problem. So minus 4, 8, 0, right? So we are going for directional derivative. So what's the formula for directional derivative? Which is grad f at the point P dot u, where u vector is equal to, right, v vector divided by absolute value of v vector. So what's your v vector? 2i plus 5j. So 2i plus 5j divided by square root of 2 square plus 5 square, which is 2i plus 5j divided by 2 square is what? 4 plus 5 square is what? 25. So it is going to become what? 2i plus 5j divided by square root of 29. So which is equal to 2 by square root of 29 and 5 by square root of 29 in the vector form, right? Yes, vector bracket. So let me take grad f, which is minus 4, 8, right? Which is going to become what? Minus 4, 8. So let me write minus 4 comma 8. Okay. And then it has a dot product with u, which is 2 by square root of 29 comma 5 divided by square root of 29, which is equal to minus I with I, j with j, minus 8 times divided by square root of 29 plus 40 times square root of 29, right? So which is equal to what? 40 minus 8 is 32 divided by square root of 29 is your directional derivative. Okay, right. So your directional derivative is what? 232 by 29. So this finishes your exercise. I'm not remembering, which is 14 point what? 6, which is 14.6, right? 14.6, let me check. Yes, this is equal to 14.6 is over, right? So the last but one exercise is there, right? I think hope that you helped you understand gradient vectors and directional derivatives clearly, right? Don't forget the full PDF, which is available in the pinned comment. And if you really love this video, please like, share and comment the video. And follow me on Twitter, X at Zahir2620034 for daily math tips, and hit the bell icon so you never miss a video. See you in the next one. Keep learning, keep growing. All the best. Take care. Bye bye.